The Moon has always been a silent guardian, stabilizing our axis, creating tides, slowing our rotation, nurturing the conditions for life. But what happens when that guardian slowly walks away? The truth is, the Moon is leaving us. Since it was born from the fiery collision that shaped our planet over 4.5 billion years ago, the Moon has been drifting away. Laser measurements from the retroreflectors left by Apollo astronauts have confirmed this. The Moon is receding at approximately 1.5 inches, 3.8 centimeters per year. At this rate, over the span of billions of years, its influence will continue to fade. Fast forward 500 million years from now. The Moon is now so far away that it can no longer fully eclipse the Sun. Total solar eclipses, once breathtaking marvels of cosmic geometry, will become impossible. Future generations, if any exist, will only witness annular eclipses, where the Moon covers the Sun's center but leaves a glowing ring of fire around the edges. And this is just the beginning of a greater unraveling. The further the Moon drifts, the weaker its gravitational grip on Earth becomes. One of the first and most immediate consequences will be on Earth's axial tilt. Currently fixed at about 23.5 degrees, this tilt is what gives us seasons. The Moon's gravitational tug stabilizes this angle, preventing it from wandering too far. Without the Moon's steadying hand, Earth will begin to wobble chaotically. This isn't a gentle sway, it's a violent swing. Earth's tilt could vary from degrees, no seasons, to 90-degree, extreme seasons, as it responds to the gravitational influences of the Sun, Jupiter, and Saturn. Such instability would bring climatic chaos. In one epoch, the Arctic might receive constant sunlight and melt into a swamp. In another, the equator might freeze solid under year-long winters. Entire ecosystems could collapse, unable to adapt to the wild shifts in sunlight, temperature, and rainfall. What's more, as the Moon recedes, its ability to generate strong tides will diminish. Already our oceans rise and fall with a rhythm set by the Moon. These tides oxygenate water, influence marine life, and shape coastal ecosystems. Without strong lunar tides, marine biodiversity could plummet. Coral reefs may bleach, fish migrations could stop, algae blooms might stagnate. Even Earth's rotation will continue to slow. Right now, our planet spins once every 24 hours. But in the far future, this could extend to 30, 40, or even 60 hours per day. Long days would mean longer exposure to solar radiation, scorching half the globe, while the other half freezes in darkness. Temperature gradients would become extreme. Weather systems could break down. Sleep cycles, circadian rhythms, and biological timing, as we understand them, could be lost. Life would have to adapt or perish. And this isn't merely theoretical. Astronomers already observe other planets with chaotic axial tilts. Uranus, for example, lies nearly sideways, with its poles facing the Sun. Mars, without a large moon to stabilize it, also experiences massive axial shifts. It's one reason Mars has such unpredictable climate swings, and likely one reason why life there, if it ever existed, never took hold in a stable way. Back on Earth, the slow disappearance of the Moon would even affect the shape of our planet. Right now, the Moon's gravity pulls up a tidal bulge, not just in oceans, but in the crust itself. As this influence weakens, Earth's equatorial bulge may lessen, subtly reshaping ocean currents and wind patterns. And with no stabilizing tides to slow Earth's spin further, another equilibrium might eventually be reached: tidal locking. In the extreme far future, billions of years from now, Earth could become tidally locked to the Moon just as the Moon is to us. That means Earth would always show the same face to the Moon and the Moon to us. But even that state is temporary, because long before that happens, our Sun will intervene. In about 5 billion years, the Sun will exhaust its hydrogen fuel and expand into a red giant, engulfing Mercury, Venus, and possibly Earth and the Moon. Our twin celestial partners, who have orbited each other in a delicate gravitational embrace, will die together, swallowed by solar fire. Their long journey, shaped by cosmic collisions, tidal dances, and evolutionary miracles, will end not with an explosion, but with an incineration. And yet, perhaps that's the most poetic finale possible. Earth and Moon, born of the same celestial trauma, forged in a single moment of cosmic violence, will vanish as one together. Still, long before that distant doom, the Moon's retreat will have rewritten the story of life on Earth. Our comfortable, stable planet will no longer be a haven for complex life. The Moon's departure will unravel the system it helped build. We may think of the Moon as passive, silent, constant, but in truth, it is a dynamic architect of our survival. And as it fades, so may we.